Hello everyone, this is SQL Dan and welcome to another episode where we're taking a look at SQL statements running in Snowflake. And today we're going to talk about duplicate records. And in particular, we're going to answer three questions. Number one, what is a duplicate record? Number two, how do we find it? And number three, how do we fix it? So let's start with the first question, which is what is a duplicate record? And for this particular demonstration, I'm going to use a small data set here with, under 50 records. And it's the list of United States presidents. So within the data set, we have the names of the president, the party, the term that he served, and his birthplace. So nice and succinct. And as we look at the data set, we can see that we have one record per president. So that's kind of where we're going to go as we're looking for duplicate records. So again, the first question that I said that we're going to answer is, what is the definition of a duplicate record? And in order to define a duplicate record, you first have to know what the natural key of the table that you're working with is. So the natural key would be that element or the field or fields within the data that define a unique record. In other words, that makes one record in the U.S. President's table different than all the others. And so let's just say, for example, that we didn't quite know, and we were just going to try to do a little bit of data investigation here. And let's start by using the last name field and see if that's the natural key or not. Now, when we're looking for duplicates, the way that we do it is we write a query where we select the natural key, and then we also group by the natural key. So we have a select statement here, and we have a group by, and then after the group by, we add a condition on the group by called having, which effectively is like a where clause on the group by. Having a count of more than one. Okay, so we are looking for any last name of a U.S. president that shows up more than once in our data. When we query that, we find that there's 8 records, and on closer inspection, we think, well, maybe we haven't identified the natural key correctly, because certainly there were 2 presidents named Adams. There were 2 presidents named Roosevelt. There were 2 presidents named Harrison. There were 2 presidents named Bush. So maybe we need to do a little bit more refining on the definition of our natural key before we can actually say that we have any duplicate records, because at first glance, at least some of these records appear to be okay. So maybe for this table, we need to include both the first and the last name when we're looking for presidents. And it's okay for the natural key to be more than one field. This is what's called a compound key, when it takes more than one field to define a record, but there's certainly nothing wrong with it. But we use the same methodology that we used before in order to find out whether there are any duplicates or not. So we have the fields which comprise the natural key listed in the select statement. We add them both into the group by, and we keep our having count is greater than 1. So let's take a look at this and see if we have any that violate the natural key, if indeed this is our natural key. And we come back and we see 4 records. And, I'm going to start by taking a look at this 3rd record down right here, only because I work in this data set all the time, and so I know a little bit about this data set. And that record looks to me like maybe that's a legitimate duplicate. So we'll take a look at Grover Cleveland's record here from U.S. presidents. Okay, where first name equals Grover and last name equals Cleveland. So we came up with a name that showed up in our list of potential duplicates, and so we're now going to query and take a look at the record and see what we think here. So these are the two records for Grover Cleveland that popped up here. And we see, the names are the same on both of them. Democrat, born in Caldwell, New Jersey. But take a look at these values right here. So one shows a term from 1885 to 1889, and another one shows a term from 1893 to 1897. So legitimately, this record actually is, there are supposed to be two records for Grover Cleveland, and this is not a duplicate. What it means that once again, I incorrectly defined what the natural key of the table should be. Because it obviously needs to be more than just the first and last name of the president, because we need both of these records, otherwise one of the terms won't be correct. So let's back up once again and take a look at the data set here. And see what we think. Again, we take a look at this. So I'm going to say that I think the natural key of this table is actually a compound key consisting of three fields. That we need the first name, the last name, and the date that the term began in order to define a unique record. So let's go back in one more time. And let's go to the query that we were using previously. So we have before we just had first name, last name, and let's add the next field in here, term began. Let's also add it to the group by. So again, we put the natural key in both the select and the group by, and we keep our having count greater than 1. And now let's see what records pop up. In this case, we're getting only one record. Interesting. Okay, so we got one record for Zachary Taylor. So let's take a look and see what we have for him. So let's change Zachary. Okay, and here we go, and we do indeed definitely see that there are two records for him in the table. So that's definitely a duplicate that we need to do something about. So we've gone through now the exercise of defining what is a duplicate record. We've gone through the exercise of saying, how do we find it? And now we need to figure out what we're going to do about it. Now, if we don't have any sort of a surrogate key, like if there were a president ID or something like that and the records were different, it might be a little easier to do something about this record. But it's very difficult to delete one of these two records out of here because in Snowflake, we can't include a limit in our query. In other words, I could take this right here and I might say delete from US president where first name is Zachary and last name is Taylor. If I do that, it would delete both records, and we only want one of the records to be gone, and we can't include a limit on our query either. Whenever we have an update or a delete, we can't include a limit and delete only one of them. So this is going to raise an error right there, unexpected limit. So that's not going to work either. We've got to find some other way to figure out how to get rid of one of the records and not delete the other one. So the best way that I know to go about this is to actually insert a third record with some value that's different and then delete the two and then fix the third record to match. So let's go back once again here and take a look at this. Okay, and just for the sake of doing this really quick, I'm going to insert another record here for Zachary Taylor. Okay, so I am going to insert into U.S. presidents. Okay, and then I'm going to say select from U.S. presidents where first name, okay, last name, boom, boom, boom. We can put a limit on the insert because the insert is actually not, the limit's not on the insert, it's on the select statement right here. So we can do this, but if we do this right now, we'd still have the same problem because we would just have yet another record with the same problem, right? And we want to preserve this record but not make our situations worse. So unfortunately, instead of doing select star, we need to list all the fields out. Party, term began, term end, and birthplace, and spell birthplace correctly. Okay, so that would insert the record, but what I want to do is I want to make this other record so that it stands out to be different in some way. So I'm going to modify his party real quick, and instead of putting wig in mixed case like that, I'm going to put it all in uppercase. All right, like so. So now we can insert a record. It's going to have all of his same data, but there's going to be one piece of it that's different, which will allow me now to distinguish between it and the others. So we can see if I inserted a record here, and it didn't matter which field necessarily that I touched, as long as I didn't touch the natural key field anyway. Now at the moment we can see we have 3 records for Zachary Taylor in here. Okay, but 2 of them have the party being wig in mixed case, and 1 of them has it being like that. So now that allows us to delete those records for Zachary Taylor by just adding this additional. So we're going to delete the 2 where the party is actually correct, and we'll be left with the one that we just inserted where the party's not correct. But you can see where we're going here is that we will get rid of the 2, and now we have 1 left, and then we can fix the 1 that we have left. And let's just take a look here. I've deleted 2 of them. Excellent. And so now we can update U.S. presidents. Okay. And we want to set the party to be wig. Control X, Control V. Update U.S. president. Set the party to be wig, where the first name is Zachary and the last name is Taylor. And just like that, we've gotten rid of that duplicate record, and we are ready to go. So let's take a look and see what we got there. And let's take a look, and we'll see that our natural key query doesn't return any records. But you know, suspiciously, when we ran this before we added the term began, there were a couple of other records in there that didn't look like they were quite right to me. So I'm going to now take the term end off. That's the true natural key. But I think we have some other data errors in here as well that really need to be looked at. Now we've already eliminated Grover Cleveland as a problem, but this Andrew Johnson and this Calvin Coolidge, we need to look out also. Now, before we go any further, the way that I'm going about this, it seems really inefficient, doesn't it? Because I'm basically finding duplicates, and then I have to run yet another query to go look at the duplicates. So what I would like to do here is show you a way to do both of those 2 things at the same time here. And let's just clean up some of this stuff so I don't have too many queries to look at. All right. So here's a query of U.S. presidents. And what I'd like to do is, aside from selecting all the stuff that we're selecting, I'd like to select an analytic count, C-O-U-N-T, okay, over. And now inside of this over, I'm going to add a partition by, and the partition by will be the same fields that we were using as potential natural keys in the first place here. Okay, so basically I'm looking to count records by any combinations of these two fields right here. Okay, and oh, by the way, I also want to include all of the fields in the query. So I'm getting a count, and I'm also going to see all the fields. Now I'm just going to give this count field an alias of C just to make life easier. And this particular structure, by the way, is something that's kind of unique that Snowflake allows that lots of other databases don't allow. In most databases, speaking of SQL Server and Oracle in particular, if I want to use an analytic, if I want to use any sort of defined function plus a star, I basically have to provide an alias with the star in order to make that work. I just can't have the star hanging out there by itself like I did in Snowflake. So I would need to do something like this. However, in Snowflake, this is actually legitimate syntax, and it's okay to do this. So if we run this, I now have a count field, and I want to change the order here so that I can group all of these ones that are potential duplicates together. So I am going to add, now I said group, and this is not a group as in using a group by in the query, okay, but I do want to order it so that all the ones that have a C value of more than one show up first. So I'm going to order by C descending, and then we'll order by the president's first name and the last name here. So first name, so that way we'll be able to get the records together. And when we do that, unexpected, what did I leave out here? Oh, right there. After this, that's a period instead of a comma. Now we have a comma. It's always something. Okay. And so now we have these records that seem to be appearing twice in the database. And we need to take a look at these here because these technically didn't violate the natural key, but there's still a problem with the data that we may want to do something about here for at least two of these here. So we have Andrew Jackson, who showed up with different parties and looks like different terms as well. Andrew Jackson only served one term as president, and it wasn't in 1829. So I believe the problem that we have here is that we have a bad record for Andrew Jackson, and so he's gotten in here twice. But this one is easy enough to delete because we have a separator in it, right, that allows us to delete out of there. We don't have a complete duplicate like we saw on the other one. We have a way that we can get him out of there. And the same thing on Calvin Coolidge right here, where we look, and it looks like there's an incorrect record somebody put in here with his term of service also. It looks like they have him off by 100 years. So we can correct this one as well. So again, there's some bad data in here. That's not necessarily a duplicate, but bad data does creep in also. But that bad data is much easier to clean up than the duplicates where we had to go through all of the extra work. In this case, we can just delete these records. And first name is Andrew. Andrew with an N, yes. And then which record do we want to get rid of? Well, Andrew Jackson served right after Abraham Lincoln was assassinated. So this record right here appears to be the correct record. And this one where the term began in 1829 appears to be the incorrect record. So that also has a party of Democrats. So we'll delete that record here. And party equals Democrat. That's one of the two. Okay, and then the second one, let's just do them both at the same time because I want to check the records before we go any further. Or the other record was the Calvin Coolidge record, where the term began in 2023 and it ends in 2029. So let's fix that one as well. And so we say Coolidge, is there a D in there? Yes. Coolidge, Calvin. Okay, and this one, using the party select won't help because both of the records say Republican, but there is a field that we can use here. Let's use the term end field, and we can say term end greater than current date, right? Because that's in the future, that 2029 date. So that's probably an easy way to do it. Now, I have some ands and ors mixed together. My best practice says that when you have ands and ors mixed together, you should include parentheses to make sure that it's super clear that you got it right. I'm not going to do that right now. Instead, what I'm going to do is something that I recommend that you actually do before any delete, which is quickly convert the delete to a select statement and take a look at what gets selected. So I'm going to comment out the word delete, change it to select star, keep the same where clause, and see what gets selected. Because whatever gets selected, is it called ended? Term end? Yes. So whatever gets selected will be the same records that are going to be deleted once we change this back. And this looks like the record we wanted to delete for Johnson. This looks like the record I wanted to delete for Calvin Coolidge. So I'd say that's good to go. And so now we're ready to change the select back to a delete. We can run this. Boom. 2 records deleted, and we've cleaned up our data. So we took a look at what the definition of a duplicate record is. I showed you 2 different ways to find duplicate records. Again, the most common, an old school way to do it is to use the group by and having a count greater than 1. But to save yourself some steps, if you use the analytic function with the partition by and put the fields in here that are your natural key, and then you order by that, then that allows you to see both the duplicates and all of the other fields at the same time. Because again, the problem with the group by is you can't see all the other fields, so you don't know what may or may not be wrong with the record. But either way works as an approach to find duplicates. And then the last thing is how you go about deleting them. And when you have a true duplicate, it's super hard to delete. So I recommend inserting a new record and then deleting both of the other 2 records as the way that I went about it. So I hope this is helpful for you. I hope you liked this tip. I hope you learned something today. And I hope that if you enjoy this content, you'll keep coming back and looking for more. This is SQL Dan showing you SQL on Snowflake. Have a fantastic day.